Today, listen. Today we're going to be plugging functions into other functions, and we call those compositions. But before we plug functions into functions, let's make sure we can plug numbers into functions. So that's what our warm-up was. F of 2 is the same thing as taking our function f and replacing x with 2. So f of 2 is equal to, well, if we look at our f function, it's 2x minus 5. So 2 times x, which is 2, minus 5. What do we end up getting for f of 2 here? Negative 1. Perfect. We can do the same thing for the other function, the orange one, g. G of 2 is we're going to take our function g, and anytime we see x, we're replacing it with 2. Make sure our Chromebooks are closed right now. We should be taking notes. So negative x plus 4 turns into negative 2 plus 4. So g of 2 was positive 2. And if we remember, evaluating a function at a certain number also gives us ordered pairs. So like from this first one, we plug in 2. That's our input. We get back out negative 1. So 2, negative 1 would be an ordered pair. Or for this second one, 2, 2 could be an ordered pair. Do we feel good about plugging numbers into functions? Okay, we're going to skip these two, but we're going to bump it up a notch, and we're going to plug functions into functions. What's up, Josh?
Will we have those function outlines on our test?
Function outlines?
Yeah, like that.
Yeah, like it'll say what the function is, yes. It'll have these orange and yellow pieces on the test. Yes. Did that answer your question?
I guess. Yeah.
Like, are you saying, is this going to be on the test and is this going to be on the test?
Yeah.
Yes. Yes.
This is a problem.
Okay.
How are we gonna figure out the
Okay. So, when we plug a function into a function instead of a number into a function, we call it a function composition. So, we use two functions to create a new function. The way we write that is like this. The right-hand side, g of f of x.
What's our g?
Hold on. We're not there yet. G is just a function. So all this means is we are plugging f of x into g of x. We start from the inside. We plug f of x into g. Just like up here, we plugged 2 into g. Well, now instead of 2, we have f of x. So we're taking our function and we're plugging it into g. Okay? All you guys will need to know is how to do that algebraically. But in future classes, you might talk about this. When you do function compositions, your domain and range get a little wonky. Your domain changes to where it's only the domain of the function on the inside, and your range is only the range of the function on the outside with that restricted domain. Don't worry too much about that, but if you were looking at this Venn diagram, that's what it's talking about, is how the domain and range switch and get condensed just a little bit when we have compositions. But what you guys need to know how to do is stuff like this. You're given two functions, and you have to evaluate those functions at certain variables or at a certain value. So the first one, it says f of x is 2x plus 5, and g of x is negative 3x minus 1. And we need to find f of g of x.
Ooh,
Hold
no
on.
clue how
Hold
to
on.
just plug
I
it
haven't
in.
taught you how to do it yet, so hold on. Let me teach. You start on the inside. Do I know what g of x is? Yes. It's right here. It says g of x equals. All I'm going to do is replace that g of x with what's in here, just to make it look a little nicer.
Oh, that's free chat.
F of g of x is the same as f of negative 3x minus 1. All I did was replace this function with what it actually is. I'm rewriting it. Josh, yes.
Why do we need the F on the left side still?
The f is telling us which function it's going into. So now,
Good question.
if this was f of 2, I would take 2 and I would plug it into f. I'm going to do the same thing. I'm going to take this negative 3x minus 1 and plug it into f. So if I look at my function f, my orange function, I'm taking that function and I'm replacing x with, I'm replacing x with this piece right here. Anytime I see an x in my f function, I replace it with this. Just like how I would if it was a number. I'm not doing anything different than I was doing in the warm-up with numbers. What's up, Josh?
So it'd be 2x minus 1?
So 2, but not x. X is now this. So 2 times negative 3x minus 1. All I did was take this x and replace it with this. And then I still have the plus 5. I took the 2x plus 5 and I replaced this x with this pink part. That is all I did. I put it in parentheses because this entire thing is x. Not just one piece of it, not just the 3x, not just the minus 1, the whole thing. So whenever we plug it in using parentheses. So we plug it in. We're here. Questions on how we got here, or are we good? Okay, now we just simplify. Let's distribute the 2. I would get negative 6x minus 2 plus 5. So my final answer here is f of g of x is equal to this function, but reduced. So negative 6x plus 3.
Hey.
Just simplifying that function and rewriting the actual name of it on the left-hand side. So,
How is it not 7?
7.
That's a good, no. That's
Where did you get
That's
7?
actually a good question.
Plus 2. Oh, wait.
Negative
they're not on
2.
different sides. They're not on
Negative
different
2 plus
sides.
5.
All right.
Okay.
That's actually a good question.
So all I did was I started on the inside and I plugged the inside into the outside. We just have variables and more than one number now. Let's do it again. Kind of. I'm going to skip part A. Do we feel confident about being able to do part A, plugging a number in?
Yes.
It was in the warm-up. I'm going to skip them for time's sake. Let's do part B. Part B is very similar to part A, but with an extra step. Let's start on just the inside. Here's the inside. Last time, our inside was already given to us in the problem. We replaced it with what was given. This time, we don't know what g of 2 is. Let's find it first. I'm doing just the inside pink piece first. So to find g of 2, I plug 2 into my pink function g. So 3x is 3 times 2 minus 4. And I get positive 2. Now I have the pink part. Just like what I did up here, I'm going to replace that pink part with what I know it is equal to. G of 2 is 2. So now, g of 2, my question, that pink part is replaced, and it's going to look weird because that pink part is just becoming 2. It looks weird. It looks like we didn't really do anything. But I handled the inside because I found out what it was. I got a number back. My original question was g of 2. G of 2 was 2, so I just replaced it. It almost looks like I did nothing. The only reason it looks like I did nothing is because I plugged 2 in and I got 2 back out. If this was like a 3, it'd be a little easier to see that stuff is actually happening here. Questions on how I just got to g of 2?
No.
I started on the inside.
There's 2 G's.
I know. That's okay. We take it piece by piece. We start on the inside, I do it. I did the inside, I got 2. I took the inside piece and I replaced it with what I just got. And now I have this. All I did, okay, listen, one more time. I ignore everything except for the inside. This first line, I'm only dealing with the pink part. I evaluate the pink part, I get a number. All right, are we good to here? We got this number. Okay. Then I go back up to my original problem. That pink part, I just got a number for it. Let me replace that with the number. All I did was take this and replace it with the number that we got. Yes, it's the same. That's why it looks weird. It's the same. Yes.
Can we just do another one? Because I think
We will do another one. We will do another one. But we have to finish off this one. This
Wait,
reduce.
that's not done
Shush. No, this reduce. Listen. Hey, shush. This reduced to G of 2. We already found G of 2. What's G of 2?
2.
2.
I was about to be wrong.
So my entire thing, G of 2, is just 2. Looks weird because there's a lot of 2's and there's a lot of G's. All we did was keep plugging in the stuff, the new information that we got. Let's do another example without as many 2's and without as many G's. Let's do part C.
Okay.
F of x minus 3. What am I plugging in to this function f? What am I replacing x with? Is that an answer, Josh, or a question?
F.
No. What am I replacing x with?
The f of x equals 203.
I'm replacing it with x minus 3. So I'm looking at function f, and anytime I see an x, I'm going to replace it with x minus 3. So 2/3 x minus 3 plus 1. You have to use parentheses or your answer will be wrong every time. So use parentheses because that entire thing in parentheses is what our x changed into. Then we distribute. We end up getting 2/3 x. And then 2/3 times negative 3 would be negative 2 plus 1 gives me negative 1. Kind of skipping through the simplification step just a little bit. But all I did was plug this function in for x. Question?
So when we now insert -1 with the x.
No, we're done. We did the outside. Once you do the outside letter, you're done. We did the f part. We plugged something into f. We're done. Yeah.
Will there be questions like example beyond the question?
Yes. Probably not as mean. Like G of 2 would maybe be 4 instead of 2 again. I don't think I did anything to where it's that hard to keep track of. But yeah, compositions will be on there. But I don't think I gave you any weird numbers like that. Any other questions? Let's do it again. This time, instead of it directly giving us the function we're plugging in, we have to plug in a function that's known. They just didn't write it out for us. So for part D, f of g of x, I'm going to replace what I know. Let's start on the inside. What is g of x? Go ahead. Anyone?
3x minus 4.
Okay, so I'm replacing g of x with 3x minus 4. Boom. That's all I did. I replaced g of x with what I was told it was equal to. Now I plug this into my outside function, into f. So I go to my yellow function, f. Anytime I see an x, I replace it with 3x minus 4. So 2/3. I'm looking at my yellow function now. 2/3 times x plus 1. After you plug in, don't stop there. Make sure you get the whole function. We had to do the plus 1. So it was in our function.
Distribute.
We distribute.
What's 2/3 of -4?
Negative 8/3. Serious, negative 8 thirds.
Alright.
Leave it as a fraction. We get 2x. And then, like I just told Nolan, 2 thirds times negative 4 is negative 8 thirds.
Plus 1 is negative 12.
Plus 1.
Is
1 is 3 over 3.
negative 5 thirds.
Yeah, so our final answer, negative 5 thirds. F of g of x is equal to 2x minus 5 thirds. What's up, Josh?
How'd you get 3 over 3?
I just changed this 1 to a fraction. 3 over 3 is the same as 1. Just rewrote it so I could combine those fractions. You're going to be dealing with fractions today. Use your calculator if you can.
I don't have the calc.
You should have a calculator. Also, bring your calculator on test day on Thursday because I do not have enough for the whole class to use a calculator.
I put dibs on one.
There is no dibs. So it is first come, first serve for my calculators, but you are expected to bring your own. That was in the syllabus. It was in the required materials. You should have your own. If you don't, it's first come, first serve on test day.
May I use Desmond's calculator on my paper?
No.
What if I don't have a calculator?
And you can use one of mine. Hopefully everyone else got one, but try to get one. Josh, you probably need one. Okay?
Well, what if they're all gone, Eric?
Okay, next one. We're going to do it the other way. We're doing g of f of x. So this time, if I start in the middle, I'm plugging f of x, my yellow function, into my pink function. So all I did was take my f of x and I replaced it with what I know it is. And then I plug it into g. Anytime I see an x in g, I'm replacing it with 2 thirds x plus 1. So g is 3x, so 3 times 2 thirds x plus 1. That's the 3x part, and then minus 4. Most of you, not most of you, but the mistakes that will often happen is you plug it in and you're done, you're happy about it, but you forget the plus 1 or the minus 4 off to the side. So make sure you do the whole function. If you reduce this for time's sake, I'm just going to do it for you. You get 2x minus 1.
Wait. Wait.
2x plus 3 minus 4, so 2x minus 1. Notice how g of f of x and f of g of x are not the same. 2x minus 1 is not the same as 2x minus 5 thirds. So it matters what function's on the inside versus the outside. It matters which one you're plugging into the other because they're not going to be the same. So we always start on the inside. Questions on that? Let's skip this one. Let's go to the next one to deal with some fractions. So,
It's the hardest class I'll take in high school.
probably not. This first one, it says f of g of 3. I'm going to start on the inside. I'm going to find g of 3. Usually the inside's given to us, but here it's not. We have to find it. So to find g of 3, I take my g function, my yellow function, and I plug in 3. So 3 over 2 plus 1.
Why is it 3 over 2?
I took this function, I replaced x with 3. And I end up getting 5 halves here. Or 2.5, whatever you are feeling. Okay.
Whoa.
Where did you get 5?
3 halves plus 1 is 5 halves. Plug it into the calculator, it would give it to you. Yeah?
1.5.
All I did was this part, Josh. 3 halves plus 1 is equal to 5 halves.
So if you put 1 in 1,
That's fine. That's fine. 2.5 is fine. Okay. Now I have g of 2, or g of 3. I have the inside part. So my new actual question is f of 5 halves. I'm replacing this g of 3 with what I just found it to be. So now I take 5/2 and I plug it in for x in this function,
Come on, Jack.
which is going to give us some weird fractions that we have to reduce.
You said, Kate.
Listen, we will talk about reducing it. Okay. All I'm going to do is take 5/2 and plug it into the orange function. So 5/2 plus 3 over 5.
So it's over.
It's over, which is weird.
It's easy.
Let's combine the top first. 3 is the same as 6/2. So 5/2 plus 6/2 is 11/2. Again, you could do it in the calculator. It would give you 11/2 or 5.5. Okay, here's a trick. Fraction divided by something else. You just take the two numbers that you're dividing by and you multiply them. And you write it as one fraction. So we just take that 2 and that 5, we multiply them, we write it as 11/10. When you divide and then divide again, just combine the things that you're dividing.
It's free. So that's our answer?
That's your answer. You would say f of g of 3 is equal to 11/10.
Oh, it's 11/10.
11/10.
11/2.
Questions on that one? Let's skip part B. We did one very similar to like that up here, and part C up here. So let's go to part E. We'll go to part E, but let's do part C real quick first. Let's do part C. F of x plus 1. If I look at f of x, is x changing at all? Am I plugging anything into x?
No.
No. So f of x plus 1 is just my f of x function, x plus 3/5 plus 1. We're just adding 1 to the function. We add it on the outside. We're not plugging anything extra in. Then we reduce. I think I talked about this early on, but reducing fractions like this, we can split up the numerator. So we can do x/5 plus 3/5. Do you guys remember me talking about that 2 weeks ago maybe?
No.
Fraction rule, if there's just a number in the denominator, you could split up your numerator. So x/5 plus 3/5 plus 1. I would get used to this step because you'll have to do this in your homework. Splitting things up. Because we want to combine these like terms here. And then 3/5 plus 1, that could be a calculator problem.
Do you cross multiply those or no?
No, you can't cross multiply because on the left is just like, this is just a function.
Oh, because there's
Just like y.
There is an equal sign between the fractions. Then you could.
Yeah, if this was x/5 equals 3/5, sure. But we can't cross multiply, we just combine these. 3/5 plus 1 is 8/5. So your final answer here, f of x plus 1 is equal to x/5 plus 8/5.
If I put x/5 plus 8/5, would that be the right answer?
I want you to tell me the name of your function. So I do want you to rewrite this part. Tell me what's equal to the thing that you're giving me. Questions on that one?
Is this the last thing we learned before a test?
This is the last lesson and the last homework. Okay, let's do part D.
Why couldn't we conjoin this with the next unit?
Huh?
Why couldn't we conjoin this unit with the next unit?
That's
Yeah, 'cause
just
that'd
not
be
how
so
it
much
works.
easier.
Okay, part D is going to get ugly. We're going to start on the
No,
inside.
it's not.
I'm going to replace g of x with what g of x is. What's g of x? Someone read it to me. x/2 plus 1. I just replaced g of x with what it is. Now I'm going to take the x/2 plus 1. And I'm plugging it into f right here. So it's going to be lots of fractions.
Oh my god.
So
x plus
x/2 plus 1 plus 3 over 5.
I feel like
Okay.
Wait.
Whoa.
I would, use parentheses. And then we can combine like terms. Let's add the 1 and the 3 on top. Let's simplify first.
So it doesn't matter if it's in parentheses. We can add the 3 even though those are not.
Yeah, because these parentheses aren't really doing anything right now. I put them in there out of good habit, but they are not doing anything. So we can do 1 plus 3. It's still being divided by 5. Okay, I have something plus something divided by a number. I split it.
Oh yeah, that's all.
I split it. So I get x over 2 over 5 plus 4 over 5. Same fraction trick as before. X over 2 over 5 is equal to x over 10. You multiply those two numbers. So we get x over 10 plus 4 over 5. And that's it.
And that's our answer?
Mm-hmm.
God, we're good.
For most of these, you're not going to have a number. Most of them, you're going to have something with x's. What's up?
For problems like C and D, do we put the two fractions back together or do we leave them apart?
Leave them separate. Try to put it into like y equals mx plus v if you can. Like something times x plus a number. Leave them separate. Very good question.
Look what we just did.
Okay,
Yeah, just simple fraction work.
let's do these two. I want you to try on your own. E and F. Try on your own or with the people around you. I'll come around. We'll check them. But try your very hardest on your own. I want to see how much we're getting it.
The whole class to fail this test. Can we get it a curve to an F?
No,
I should have. I didn't even realize.
I won't curve because every
No
year.
curve at all?
No, because there are 2 algebra 2 classes. We teach the exact same problems, the exact same lessons. We would both, actually, it's 3 classes, like 3 teachers, and we would all have to curve it if I curved it.
So do we plug in for? Is this gonna be G on the side and then you plug X in for F of X? Bro, yes. Bro.
Yeah, so you're going to plug the orange into the yellow.
This doesn't even make sense.
Okay, so
Start by writing down what you know.
X.
You're just plugging it. And the hardest part for this whole lesson is going to be the reducing part. The fractions are going to suck. The plugging in part should be okay.
Look, Jack. X plus 3.
Yeah.
Is X plus 3 over
Combine your 5 and your 2. So make it 10, x plus 3 over 10. And then you'll split that fraction up.
Oh, wait. So you have to do over 5 over 2.
Again, the hardest part is the reducing part, and I know that. The fractions. How are we doing with our fractions? Oh, very nice. Why'd you get that? Oh, from here?
So now
Combine the 5 and the 2. So
No, I watched
so this is
yesterday.
the fraction on top of the number. And then split up that fraction after you combine your denominators. Once you split it up, you'll be able to add stuff to the
Oh,
one.
I think we're correct.
Because why would she
X over 10 plus 13.
Okay, so I split it.
Yeah, you can totally, this works. Yeah, and then split it up, so x over 5 over 2. 3 over 5 over 2.
I
And then over here
think
is
E over 10 F. Wait, can you come look at this?
Yeah.
Jordan, I can't do myself.
brain's going
Let me help you.
I think I got it right.
Oh, so 3 over 2.
Good.
Yes!
Let me walk you through it.
No, explodes.
So first, you got it in now.
Working now.
I don't know what to do.
Get to one denominator. What did you get? So you go 5. So x plus 3 over 10. So these x will plug your denominators together.
I bet on the board for like the past 3 years.
Okay, so we're gonna take the x over 2 plus 2. We're gonna plug it into g here, so we're plugging it into.
Not bad, but like I'm not working now. I'm drinking my creatine.
But you really don't have to.
Anyway,
Here's it.
uh,
This is how we're plugging it in g. I know, yeah. All right, just for time's sake, let's do these ones together. So for the first one,
I'm so bad. I mean, I just cooked and I got it right.
I know the fractions are going to be the hardest part, and that's okay. We're going to practice. And on your test, you won't have as ugly of fractions as you might have on your homework. Step 1, replace the inside with what I know. I know f of x is x plus 3 over 5, so I'm going to replace it. That's step 1. Step 2, plug this into the outside function. So here, I'm replacing this x with this entire fraction. So I end up getting x plus 3 over 5, that's x, over 2 plus 1. It gets ugly.
What?
It will get, anytime you have fractions like this, it's going to get ugly with compositions. I'm sorry. We got to be good with our fractions and reducing. So then we reduce. Let's make this have just one denominator. How would I combine the 5 and the 2 into one denominator?
Multiply.
Multiply. So x plus 3 over 10 plus 1. We're still reducing. We have a fraction. I can split it. So we get x plus 10 plus 3 over 10 plus, I need common denominators. How do I write 1 as a number divided by 10? Yeah, 10 over 10. And my final answer is that g of f of x is equal to x over 10 plus 13 over 10. After we combine the 3/10 and the 10/10. So I know dealing with fractions is not the most fun thing in the world. Make it one denominator, split your numerator, and then combine like terms. Questions on that one? Okay, your homework today is just a worksheet. Before you get your worksheet, I want you to try to do F and G of the next problem on your own with the people around you. I'll check it. Once I check it, you'll get your worksheet. Deal? Hold on. So again, raise your hand when you're done with it. I want to check it before you get your worksheet. See what you're plugging into what? Okay.
You can do S. You can do S.
What you know.
Do you want to do S?
Start there.
No, I'm
You
doing
know
it.
F of X. Rewrite it into what you
How
know.
is that even gonna
Like
measure?
5 hours.
How will that even
5 whole hours. No nap, nothing.
Very well done. Yes. This can count as one down here. That works. Hey. Yep. Good. Distribute and then reduce the top as much as you can.
Alright, bro. Yo, Miss Cruz, you got pliers?
Don't let me.
No.